So good afternoon. Welcome to this GÉANT Infoshare, which is related to white box in NREN context. I am Xavier Jeannin from RENATER, and I am the task leader of the Network Technology Evolution Task, which is part of a network on service development work package 6. In this work package 6, there is a subtask called white box for research and education, and this InfoShare will present the result of the studies that has been made on this white box. The purpose of this task, this subtask, is of the white box for research and education was to evaluate whether white box technology is a real opportunity for the research and education community. Our approach is very pragmatic. It is based on the use case. The idea was to really take different NREN use case to evaluate them and possibly to put this in production. So we have defined a kind of methodology for this. There was in the first step for each use case a technical validation where we study switch and the routing features, the management features, that include also the security. We also look at the management aspect with the maintenance, and also how to integrate in your router estate this new white box, this new network operating systems. We look also at the business model. We look also at the financial aspect, especially about total cost ownership, because it is one of the interests of the white box to be relatively cheaper than the traditional vendor routers. We also look at the strategic aspect because it's also very important for the final decision. When even if a white box is validated at technical level, validated at management level, I mean network management level, even if it is validated at financial level, there is still a strategic aspect that is decided by the management of your institute. Because for instance, strategic aspect, for instance, for the willingness to be independent from the traditional vendor, or to be sure that, for instance, the production of this new white box is compatible with the strategic plan of your institute. And when all of this step has been made about these use cases, the different NREN who take part into this white box have a validation phase, and if the use case, the usage of the white box for this use case is validated, then we go in production. And some of the use case was really put in production, and in this case, we documented the feedback of this deployment. So the different use cases that has been studied is the following: small CPE, a large CPE, a CPE for a larger site, a programmable CPE, which is really interesting because it's a CPE on which you are able to put an open source and also to modify it. And it is made thanks to RER, Router for Academic Research and Education. We also study provider routers, data center fabric, and the global internet exchange point. All of these studies are documented in our public wiki, and there is also on the deliverables that is here some interesting information related to this project. But before we start, I would like to recall you exactly what is a white box. And so our speakers after that will focus mainly on their use cases. So we take a definition for the white box, and this is the following. A white box is a switch or routers that is built from commodity component. When I say commodity component, I mainly think about chipsets that you can buy on the shelf, I would say. You can buy from, for instance, a Broadcom or Mellanox to build your own routers. And on this white box, what is really interesting is the property of being able to put different network operating systems. So with this, you have a decoupling effect from the NOS, network operating system, from the hardware. So you are able to change the network operating system, and you are able to change the hardware independently. And this is, I think, the major interest of the white box. So in the proprietary, I would say, business model, when you buy traditional routers, in fact, you buy 4 things. You buy the hardware with this maintenance, and you buy the network operating system with the maintenance of this proprietary network operating system. So you end up with a dependence from your provider that could end up with what we call a vendor lock-in. It means that when you are started to buy some routers, you are obliged to continue to buy to this to the same vendor to continue your deployment and so on. At the opposite, the white box in the white box world, I would say, the business model is different. You buy 2 things. You buy hardware to a hardware provider with the maintenance of this hardware, and you buy a NOS to a software provider, and you buy the NOS with its maintenance. As we have seen, in general, for now, the white box is based on commodity components, and it provides you a relative independence from your provider because you are able to change the network operating system, or able to change and keep your hardware, or the opposite, you are able to change your hardware and keep your network operating system. And thanks to this, you avoid a vendor locked effect. Last point before we see our speakers is the way you install this different network operating system on the white box. So I just mentioned this because maybe you have not the opportunity to play with this. So in order to install on this white box a different operating system, an interface has been developed to allow you to install this the different operating systems you would like to install. This interface is called Open Network Install Environment ONI. So it's very simple. When you start your ONI white box, you have a menu that is just that appears, and you choose to, for instance, erase the current network operating systems, or install another one, and so on. And so you just have to play with it, and after that you can install the network operating systems that you would like, and that is compatible with your white box, of course. Other white box has not only interface, but is based on Linux system. So you have a Linux that is installed on your machine, and on the top of this you install a network operating system. So with this, you have the basic information that allow you to follow this InfoShare. So during this InfoShare, we will mainly see some feedback from the different studies, as I mentioned, and to the different experience where white box were put in production. So we'll see first an implementation in production of the Global Internet Exchange at RENATER from Maxime Wisslé. After that, we will have an implementation of a CPE for Normandy High School from the regional network of Normandy SYVIK that is put in production. After that, we have a study of CPE for a larger site, universities site like this from FUNET. And we will see that in this case, this use case was not put in production. And after the break, we have seen GRNET will present us an implementation in production of a data center based on a white box. We'll see an interesting speech about a CPE that was put in production based on a programmable white box from the University of Murcia, from Jordi Ortiz. And after that, we will have a final presentation about the network device validation. At the beginning of our study, lot of NREN network engineers mentioned that okay, it's nice to validate the features. It's nice to validate the management, the network management of the white box. It's also nice to study the maintenance aspect, the cost, and so on. But at the end, how we can be sure that this white box with this network applications that we have chosen is providing the performance expected for this specific use case that I would like to implement. And this leads us to this question, to how we can test a different network device and how we can ensure that it will achieve the performance that we would like. So this is what Tomasz Szewczyk from PSNC will present it to us, and I think it is a very interesting topic. And with this, I am done for the introduction. If you have any questions, please ask. And okay, I see that there is no question. So therefore, I have just to introduce Maxime Wisslé. Maxime Wisslé works at RENATER as a network engineer, and he has studied white box and implemented in production global internet exchange. And he will present us the result of the feedback and the result of this implementation. Maxime, the floor is yours. Thank you.
Okay, so I will introduce you the RENATER GIX implementation based on whitebox. So first of all, what is a GIX? GIX provide the physical infrastructure for traffic exchange between autonomous systems by providing their user a layer 2, a LAN, to interconnect the user so they can perform BGP peering. So they can exchange routes on traffic, and in fact that optimize the performance on the costs. So RENATER has a GIX called Sphinx, and this GIX was created in 1995. The Sphinx has 2 points of presence in Paris in 2 data centers. The Sphinx has 2 root servers and 35 peers. So you can find more information in the peering database website at the dedicated page for the Sphinx. So first of all, what is the initial architecture before the migration? As you can see, there is 2 switches directly connected with 3 10 GB per second interfaces configured in lag mode. Each switch is connected to RENATER backbone on 2 end users. A set of VLAN is configured. The VLAN with ID2 for unicast traffic that allow end users to perform peering between them. VLAN ID5 for multicast traffic, and the dedicated VLAN ID for RENATER management. Of course, only the RENATER NOC and RENATER team can access the management VLAN. RENATER use the VLAN 2 as well to perform peering with other users. So what was the goal of using whitebox into the RENATER GIX? The goal was to renew the Sphinx with the same feature, but with a total cost ownership that must not exceed the previous infrastructure. The goal was to increase our independence from traditional vendors, as Xavier said before, and get ready to deploy new features like EVPN on VXLAN, and so on, this type of feature, and finally gain experience on whitebox paradigm. So here you can see a requirement about feature to renew the Sphinx. These are a common feature. the operation and management like out-of-band access, management access with inbound port, with SSH and so on. The security requirements, especially at IP layer with IP-ACL and MAC layer with MAC-ACL. The routing and switching feature, in our case, VLAN, spanning tree on the functionality like EVPN or VXLAN for future projects at Sphinx, and of course, performance and reliability requirements. Here you can see the implementation we choose. On the network operating system side, we go for OCNOS from IP Infusion. We choose this one because it was already deployed in the London Internet Exchange Point called Links, and because it has MPLS feature on the competitive software maintenance. In terms of hardware, we go for a Dell S4048ON. ON here stands for Open Network Install Environment, or ONI. We choose this device because it supports several NOS. So if we need to test any other NOC compatible, we can choose any other network operating system that is compatible. So if the network operating system do not provide the features that you need, you can change a NOS and go for a NOS that provide everything you need to deploy your functionality. In terms of component, we find the same element that is used by traditional vendor. For example, the Broadcom Trident 2 chipset. Cisco use this chipset for their Nexus, for example, on Juniper as well for some of their devices. So as Xavier said before, you find the same components in white box than in traditional vendor. Okay, all the feature implementation was going with this network operating system for each of our requirements. We start by testing out-of-band access. The purpose was to take control over the out-of-band network, to manage the device, and if necessary, install or reinstall a NOS, a network operating system. Indeed, to access ONI and install a NOS, we need to use the serial port. And then after you are connected to the serial port, you need to provide the path of the installation file. You can set up the installation file directly into a USB stick or download the installation file from the management interface by FTP, HTTP, SFTP, and so on. So you can perform an installation with only a USB stick and no access to internet or network, or you can use the management port and use HTTP or FTP to get the file. After that, we implemented the inbound management. We encountered some problems about the restriction needed in the inbound port, but we finally find a solution to set the restriction correctly in the SSH users, for the SSH users. Next feature was authentication and authorization. Our prerequisite was to use the RENATER backbone TACACS system. So this is the TACACS that was already deployed for all the RENATER device. And our test shows that OCNOS support TACACS, but the configuration deployed in the RENATER server, TACACS server, was not compatible for the authorization. Indeed, once we configured the white box with the TACAC server configuration, we can connect to the white box with the user that we used on all the RENATER backbone, but the authorization was not set properly. It was everything or nothing, depending on which group the user was configured in the server. So if you was a super user in the TACAC configuration, you get everything on the white box, and for any other group, you get nothing. No, right? You can only make a simple command like show version. We perform tests with a dedicated server. So I just put a TACAC server on my computer and test this server with Oknos, and I implement the configuration provided by the Oknos team on the Oknos documentation, and everything was working as expected. The write, the authorization, the authentication, everything was working, but you have to set up the configuration provided by Oknos. So we made a trade-off here by using the RENATER TACAC system, but with suboptimal authorization. So it was easier to implement directly the white box with the actual TACACs than to set up a new server just for this white box. So we made the trade-off. For the logging feature, everything was working as expected. The configured log was properly sent to a log server. About the monitoring, we implement SNMP and it worked without any problems. We checked the automation as well with Ansible. An Ansible module on playbooks are provided by Infusion for Oknos. So it was really easy to test. I just follow the documentation and use the playbooks provided, and everything was working fine. For the security, in our case, we was interested about IP ACL for management restriction and make ACL to ensure the correct user is connected to the white box. So for our case in the GIX environment, we was really focused on the make ACL because we need to be sure that this is the good user that is connected to the white box. But actually, the two white box are in a data center, so there is a low chance to another user to take the wrong ports. We test the broadcast control as well, and everything was working fine in our lab when we performed the test. So what about the last implementation on the routing and switching feature, like VLAN, RSTP, and the other feature like EVPN or VXLAN that we can eventually use in the future for the Sphinx. So our test about VLAN, EVPN, and VXLAN was a success, but we encountered some problems with RSTP. Indeed, the white box on the old Sphinx switch cannot work together with RSTP. We test many configurations to make it work, but the Oknos support and the Oknos maintenance team confirmed us that it was just not compatible between the old switch of the Sphinx and the white box. So we had to make a workaround. We had to make a workaround, and we create a loop-free physical topology to be sure that we do not have some broadcast storm problem. During our test, we discovered a bug that drastically slowed down the white box. This bug was caused by the Dell switch, but by the BIOS of the Dell switch. But to check this bug, we performed a web meeting with the developer of Oknos, with the developer team of Oknos, and they provided after our meeting a patch that solves the bug. What about the total cost of ownership? We calculate the total cost of ownership by using the white paper white box total cost of ownership on the datasheet TCO calculator. The link are provided in this InfoShare. So our assessment confirms that the new version of the Sphinx was significantly cheaper than the previous architecture. So this goal was met. Now let's talk about the migration plan we deploy to migrate the old Sphinx to the new Sphinx with the white box. So here you can see the initial topology without the white box. So there is two switches directly connected with 3 10 gigabyte Ethernet interface. These switches are connected directly to the RENATER backbone and connected to the end user. So first, we introduce the two white box. You can see the two white box on the picture. And to interconnect the two white box between them, we take one of the 3 links that connected the old device, and we connect one of the white box to one of the old switch to avoid any physical loops. So here you can see there is no loops in the layer 2 architecture. This is we made this physical loop-free architecture because of the incompatibility of the RSTP between the two white box and the two old switch. So the last step was to migrate all the end user, user by user, to the white box. So we performed this, and when all the user was migrate to the white box port, we took the two 10 gigabit link that was available between the old device, and we put this link on the white box. So in the right of the presentation, you can see in the top, in the right top, the bandwidth statistics of a user, or in the bottom, right bottom, the statistics of the link between the two white box. So there is traffic and everything is working as expected. So in conclusion, our main goals was achieved. The RENATER GX Sphinx was renewed with similar set of features and even more features for future deployment, like EVPN or VXLAN. All of that with a lower cost and more independence from traditional vendors. And today, the white box are still running in production, and they was running in production for several months without any problems. A good point for Oknos, it was easy to get started with this network operating system, because if you are accustomed with Cisco CLI, you can easily perform basic troubleshooting, because the commands in the CLI are for majority of commands are the same in Oknos and in Cisco. So the RENATER NOC and the RENATER team used well Oknos without problems. And last but not least, we gained experience in white box. So in case of a specific project or to renew a device, if needed, like the Syncs, because the two device was old and needed to be replaced. Now we can consider using white box for our project and for replacement for old devices. Thank you.
Thank you, Maxime, for this presentation. We have a question for you in the chat from Italo. Would you like to ask it directly, Italo?
Alors, let me check. Okay, there is a question. Which specific test? Sorry.
No,
which specific test? Which specific test have you done for Ansible? Checking state, creating VLAN, configuring spanning tree. For Ansible, we perform basic tests like getting the configuration and configure some management component like NTP, hostname, and so on. So it was a really basic test, but it worked well without any problems. No problem. Any other questions?
Okay. If there is no other questions, thank you very much, Maxime. And I will ask to Sébastien Vigneron from SYVIK, from the Normandy Regional Network, to present us his implementation of CPE using a white box. Sébastien, the floor is yours.
Hello, everyone. So my name is Sébastien Vigneron. I'm from France, specifically in Normandy. Here at CRIANN, we manage the SYVIK regional network for Normandy. And I will talk today about our little project we was mandated by the Normandy region in the last few months. So here is the situation. SYVIK, as I said, is the Normandy regional network for education and research, and it is connected to RENATER, the French NREN. The region, the Normandy region is a client of the SYVIK network, and they manage all high schools in Normandy. So what is our use case and goal in this? So CRIANN was mandated by the Normandy region to evaluate white box solution in order to renew CPE routers in the whole Normandy high schools. So we need to replace all vending-locked routers in Normandy with vendor-free routing devices, and to be able to add features at no extra cost over time, at the same or lower cost than the previous infrastructure, which was composed of Cisco routers. The needs was pretty basic routing capabilities, including BGP, PBR, and VRF Lite features, some filtering, separate management network, etc. The objective was a bandwidth of 1 gigabyte for the high school, with the possibility to connect at 10 gigabytes. And also, we need remote management inbound through SSH connection, and out of band if possible. Why white boxes for CP routers? As I said, it was to avoid vendor locking and restrictive licensing. Why to pay for necessary functions or for basic functions any Linux box can do. And why pay for extra bandwidth when the hardware can already do it with some break-in suite? Actually, we tested some white box server with 10 gigabytes SFP ports, and we were able to reach nearline speed with IOMMU. It was also to consolidate network function. Why buy multiple physical appliances when one white box server can do it all using virtualization? One device takes up less space in a rack than several, and place is of the essence in high school. And we needed some centralized CPU router management. So we took an Ansible server to manage them all at a very low cost, fixed initial cost, initial development, some basic Ansible training. And it allowed us also to reduce maintenance cost. If we have some new feature we need to implement, we just have to implement some extra development budget for it. Not a big deal. And white box as router also to take system and network administrator to work together toward a common goal, each contributing with their expertise on the subject. And we can use DevOps techniques to automate and secure all the infrastructure. So white box, we can easily change one part of the system and keep the objective. It's run commodity hardware with appropriate SFP and copper ports. Today we use Dell Virtual Edge platform 4600 and 1485, but tomorrow we can totally change by a similar system. We initially use Proxmox VE as a virtualization software, but the region choice for production has turned to Citrix Hypervisor actually. And they manage all the CPE using Xen Orchestra, a web-based interface, so they can gather metrics and logs and across all high schools where white box are deployed. Also, we are using FR routing as routing software to implement the feature we needed, BGP, basic routing. But tomorrow, who knows, we can change by any available routing software, like Bird and other. Here's the two models we used on a testbed and on production. So Dell Virtual Edge platform 4600. It's pretty good hardware, but high cost, 3,000 euros per unit. It's quite expensive for an high school. So we looked for a smaller version, and Dell proposed this model, the 1685, at half the cost. Pretty cheap. So we used Ansible to configure all the CPU CPE routers we deployed inside a white box. All we have to do is to describe some network configuration specific to the high school, and the Ansible playbooks can generate and push to production the new configuration and apply it in no time. It's allow us to use some CI/CD techniques to delegate. For example, if we have a field IT technician who need to make some network changes, new subnet or something like that, he can directly ask through the GitLab project the modification he need. Then a network administrator on the region network team can review it and merge it to the main branch for this CPE. Then, with the CI/CD workflow, this trigger a dedicated deployment of the new configuration directly on production, where everything is traceable. What changes were made, who requested a change, who authorized it, and when it was deployed. Also, a rollback is also easy to trigger. So Ansible, we can use it to provision the hypervisor on the white box device, manually or automated with PXE when possible. Then Ansible can also set up the white box device by creating the CPE router virtual machine using virtualization software API. Set it up for a specific site. And we can also perform a daily operation like routing, switching management, port configuration, ACL management, and so on. When a white box device fails, a replacement unit can be provisioned in a few minutes with a configuration backup or from scratch, sent for quick on-site replacement. Here's the deployment model, where we can see the region, the main site has all the information about all the high school and CPE configuration. When they made a change in the GitLab, they trigger an Ansible playbook to push the new configuration on the white box directly on site, or on a test bed to prepare a replacement device. The CPE virtual machine is a Debian OS with FR routing software. It has 3 virtual network interfaces, one for WAN access, one for LAN access, one for management. It also has 2 Linux routing tables, one for management, one for LAN to WAN traffic. The CPE can establish 1 or 2 BGP sessions as we need. So we can connect to 1 or 2 PE routers on the regional network. We can have chosen a commercial or open source network operating system, but we had 2 constraints, time and budget. Time for first deployment, we only had a few months for the first deployment to be made. We had low time also for training, and low time interface sensible with specific network OS. And we had obviously a budget limitation for commercial network OS. Here, the CPE Whitebox project history. So from April to summer 19, it was some development, the first test on a test bed, first virtualized, then proof of concept with physical white boxes. November 19, 2 high schools were equipped with white boxes. Then the COVID-19 pandemic put on hold the deployment plans for a few months. Summer 20, we trained the region teams to operate to operate the whole project, white box project in autonomous, so they can manage all their production. In January this year, another series of high schools were equipped in Le Havre. And today we have 10 high schools equipped, and 25 are expected in the next months, and 100 to go. So what next? We have the CPE router function key, which is working. Now it's time to add additional function. So it was planned to implement some firewall, local network monitoring, maybe VoIP gateways and web proxy caches. To date, monitoring and firewall VM are deployed alongside the CPE router VMs. Thank you. Any question?
Thank you, Sébastien. Is there any questions? So I don't know if there is one, but so one of the interests of your architecture is to be able to add some new virtual network features,
yes.
Firewall or something like this.
Yes.
This is, I don't know, anything you can, it's very flexible. And for your new machine that you mentioned, which is a Dell,
yes.
What was exactly the capacity of this Dell? Is it the same as the previous one, or?
No, it is less. In the first unit, we were able to have 64 gigabyte of memory and 1 terabyte of M2 SSD storage with 2 SFP plus ports. On the smaller unit, we can only have 32 gigabytes of memory and 240 gigabytes of storage.
Mm-hmm. And is this machine? Is it on this machine that you plan to test RER or not?
We don't know yet.
Okay.
It's in the region Normandy hands right now, so we wait and see what they decide.
Okay, thank you, Sébastien. Is there any other question for Sébastien? No, so thank you very much, Sébastien.
There are questions in the chat. At the moment, 1 VM plus so 3 VM at the moment, since we have a CPE router, firewalling, and as I said, monitoring here. Debian with FR routing, yes. Was a decision on leaving Proxmox technical? Not at all. It was a region choice, so they can use Xen Orchestra as managing a platform for all CPE across all high schools.
Okay. Thank you. So now there is still really still no. So thank you very much, Sébastien. And now we start with.
So you can see my screen.
Oh yes, sorry, so I spoke better. So Jani has tested a CP solution, but a more stronger one. So Jani, the floor is yours, please.
Thank you very much, and good afternoon. So my name is Jani, and I work at CSC, mainly to maintain the Finnish RNA backbone, also an optical and back layer. But today I'm discussing about the CPE test system we had for this project. So agenda would be like this. So I will give short introduction and background for this work, requirements we had, implementations we did with the testbed, feature validation, some performance test and conclusion. So let's start from the background. So why we are interested of this kind of equipment for customer edge. So we started 2012 providing service to FUNET customers. The original idea was to give some managed platform to implement redundant NREN uplinks. So basically implement BGP on behalf of our customers, which have no experience usually. But on later date, we found that this simple model won't work everywhere. So some of the services were implemented in different part of campus network, which make it very complex in some cases. The old system based mostly on Juniper MX80 and MX104 routers or variants of those, and we built, let's say, something like 15 to 20 setups in Finland, and we use the same platform for all of our customers, which extend from the biggest university in Finland, tens of thousands of end users, to some small office of a research infrastructure, less than 10 employees. And that have been, let's say, quite successful, and it's now continued under different service umbrella, which is called FUNET Campus, Campus Network Service. And let's say, most recent implementation we have done based on the newer generation Juniper routers, MX204 or MX10003, and we have some switches for very small environments, and these systems share out backbone infrastructure, automation layers, and such on. But the problem here is that even though MX204 is very compact and let's say affordable, it's some cases it might be too big solution and even expensive. So the reason here was to try to find something between the very stupid layer 3 capable switch and Juniper MX204. Currently, we have 27 customers and around 100 router switches deployed in Finland within this service. So there are some common requirements for CPE device. So what we tried to find was a scalable solution which will fit smaller campuses or remote offices, and which can offer both the redundant and non-redundant edge router modules. Our baseline currently is 10 G, so that was the minimum we were looking for. Towards customers, we would need to provide both 1 gig and 10 gig access, because the other part of the campus environment might be might be too old to support even 10G. And one of the idea here was to look at equipment which can be upgraded to 100 gig later date, where we're changing pluggables, so that if our backbone will be upgraded in future to higher speeds, we can, let's say, migrate these existing systems to the easier way to the new backbone systems. 5 years typically the service contract we offer, and that was the requirement that the NOS and hardware shall be support. Support model is basic, next business day or return to factory. And what we were looking for was that support should be from a single channel. And this case usually it means the operating system provider. As I said earlier, TCO, the cost side should be competitive with existing solutions and preferably close to these lower end switch alternatives. And if it's something, let's say, new thing, which white box, I think, can be categorized, it should have active users within the REN commune, so that we are not the only user which use this kind of solution. The requirements for this the edge router, they were actually quite basic. So what we are looking for were dynamic routing protocols, BGP, OSPF 2 and 3, some support for stateless traffic and route filtering and management monitoring capabilities. And performance side, we are looking devices which can line rate forward packets on the interface speed sides. But the difference here, the most of the white box systems were that we were also trying to find a good router, which means user deep buffer support to support, in this case, to support interface speed mismatch. But there might be a bigger uplink and lower speed user access. And that was, let's say, the most complicated thing here. Route and forwarding information base, that's very low requirements. And usually in the smaller environment, there's a firewall where most of the users are, but in some cases there are need to have directly connected systems or even end users. And we were looking, let's say, some kind of simple systems. So the more high-end complex campus environments were out of scope here. So if there's NPL layer 2, the free layer 2 VPNs or something like that, that won't be let's say, potential use case for this. So here's this, let's say, simple structure we're looking. So basically, non-redundant setup where we have only one router, or redundant setup where we have two routers, depending on use case, which should be used. Redundant is preferred, but it's not possible in all of our users. So where we started testing Cumulus Linux, which is very common on this space. Mainly to test the control line management plane features on VMware environment, and that was actually quite good. NOS features were complete enough for our use cases, and the test environment was stable for 4 months. But after let's say we had tested the control line management layer, we were trying to start finding hardware which could support our requirements, and that was the problem thing. We discussed with Cumulus, and they did not have support for the buffer systems where you usually have Broadcom Jericho or Qumran chipsets, and they told it might be in the support in the future, but eventually they didn't. So they chose not to support it, and let's say on a later date, it seems that they will ask dropping support totally for program. So what we find finally was this device, which is made by Edgecore. It's based on Broadcom Cameron AX chipset, and it implements Telecom Infra project disaggregate cell site gateway definitions. It's meant for mobile network, 5G access and such on. But the hardware design was actually good also from our perspective. There is native support from 1 gig to up to 100 gig native ports. It's operating extended temperature range, and it's a front side access only. So very good device in many places where we cannot place the equipment in the data centers, for example. Cumulative support is, so we try to find what NOS are supported in this platform, and we found that let's say all options were very niche players, not familiar for us. So and apparently all were focused on mobile access because the device is designed for mobile access. But we have collaboration with ADVA, so we chose ADVA because they told that the features we are looking for were actually supported in NOS. So ADVA were chosen, and we sourced the hardware to routers also from ADVA. The bottom is the picture of this device. So hardware arrived, and the let's say first problem was that we tried to find AC powered routers, but those were not available. DC was the only option, so that was what we had to use, and that required external rectifiers. Hardware, when we started the system, we found that the hardware arrived without NOS installed, and the only option according to this NOS provider was to use network-based installation model, which required a bootstrap, separate bootstrap environment to install this NOS. And we also have hardware issues in the very beginning of this test. Well, one of the routers lost storage, so that was required weeks to get it back online, both using the NOS support and Edgecore support. And it did not behave correctly during test. But after we get it online, we did started feature validation to test different protocols and other things we had defined. So and in this side, dynamic routing protocol, they basically work well, and management baseline, yes, okay, monitoring pretty much okay, but during tests we found that we're missing the parts in the implementers or in box, and there are some detailed information next slide. And we also did performance test with these routers. So issues we found, BGP pretty much okay, excluding that IPv6 route filtering was not supported. Vendor told that they thought that it should be, but there was a bug. PRP, we had issues with MD5 authentication, big troubles with the DHCP4, DHCP6 relay implementations. There was limited configurability and issues. They did not work perfectly. Traffic filtering, egress filtering was not supported. I think that's quite common. With IPv6, we couldn't filter based on layer 4 port, so you can only use protocol or IPv6 address. No control plane filtering, that's a big surprise, and no real layer 2 bridging support which was not also surprised because this was mobile access. Performance test, we did those with the dedicated hardware. We also had the virtual tester from PSNC, but this performance test thought that it's better to use it hardware tester, which were possible with the Expo we had, but it was up to 10 gigabit. And we used two test methods, RFC 2544 to evaluate IPv4 and IPv6 performance with different frame size distribution and different type of test. And we also test the traffic filtering performance with more manual traffic generated multiple parallel strings. And these tests were successful. The jitter latency, there was no issues at all. So that was running on line rate, both in forwarding and traffic filtering side. And the conclusion here, maybe you can guess that this did not went to production yet, but let's say the hardware side, it was quite positive. So that looks maybe even better than MX204 on port front, in port selection front side, and it's also designed to operate every environment, and so on. So could be a good fit for our purposes. There is a limited scalability, but 300 gig usually is enough for these potential use cases. The NOS we used was recently introduced, so some of these which we found were probably bugs in the implementation. Also, it might be that the vendor focuses more on mobile side, though. So the data center specific features are not in their interest. And let's say final thing I would like to say that the hardware is open. Maybe even some kind of more open NOS could be a better solution. I find that Microsonic should support this, so that might be a good option maybe to evaluate later, and which could give better results. But from operation perspective, let's say support might be complicated if there is no real NOS vendor you can rely. Okay, that's all. Thank you very much for your time.
Thank you, Jani, for your presentation. Do not hesitate to ask a question. Is there a question? Any jumbo?
Management, there is, let's say, Dennis Wahlberg. There was some kind of filtering for example, for SSH. So that can be used, or access list. But yes, that's a problem if you need to put it into the internet. It should be implemented and preferably in hardware layer.
So there is a limitation on Jumbo frame?
No, we used the 9,200 something.
Okay.
MGU. So that should not be a problem. That's a common way to configure it.
Okay. Is there any other question?
But the test, let's say, tests were up to normal 1500 18 bytes, which were supported by the tester. So that did not use jumper frame. So we don't know for real that what is the performance, but I would expect that. It's not a problem.
Okay. Is there any other question? So me, I have just one question. So one lesson of what you have made is that the network operating systems that you use is, in fact, that we have the choice is that we have the opportunity to choose is in fact dedicated to to a use case. So for instance, you choose some, in general, the network operating system seems not generalist, just not, they are dedicated to the use case, for instance, for 5G, telecom application, or for data center. Is it your feeling also too?
I think if you look what vendors are supported, so Adva, Infinera, Xavier, Gemini. So very strange vendors, at least for me. So I think their main focus is to support this on mobile environment because the hardware is designed for mobile environments. But I don't see any problems to use this on edge if the NOS support is complete enough.
No, it's just limited the number of the use cases that could be used with this. Okay. If there is no other question, thank you very much. Dennis, you would like? No. Okay. Therefore, we will take a 10-minute break. So we will come back in at 3:30. We are 5 minutes late, but it's not a big deal. And so let's have a coffee for 10 minutes and come back at 3:30. Thank you for your attention. Oh, it's not. Sure. We will restart this this session. We will have in the second session 3 presentations. One for CPE based on a programmable white box, RER. A third presentation on the network performance tests that we have made on the white box. But we will start with a presentation on data center use cases. And that was implemented by GRNET. Theodore Vasilopoulos has implemented this, and I will present us the result of this implementation. Theodore, thank you very much for this, and the floor is yours.
Hello all, I'm Theodore Vasilopoulos, member of the GRNET Network Reliability Engineering team, and I will share with you our experience with the white box data center use case. We'll see the project objectives, the white box switches overview, the data center topology that we used, the validation testing results, and the final conclusions. Our main target was to build a new small-scale data center to host cloud resources for our customers, as well as for GRNET internal resource needs. We wanted to reduce cost in comparison with vendor solution, to improve independence from vendors and get acquainted with white box switch concept in general. Traditionally, the data center network is a combination of hardware and software components provided by the same vendor. And the white box switch introduces a concept of decoupling software and hardware. As a result, the customer can choose their own combination from a variety of network operating systems and commodity hardware solutions. White box switches have significant advantages such as freedom of choice, flexibility, option to replace either the network OS without changing the hardware and vice versa, cost savings, and being able to use open source solutions. GRNET is already operating 3 medium to large scale DCs in 3 different points of presence based on IP class topology, EVPN VXLAN, and Ansible for configuration management. So we decided to use the same architecture principles, but based on white box switches and non-hardware vendor NOS to provide layer 2, layer 3 connectivity to the cloud resources. In this slide, we see the topology that we created for our test for our data center. It is a typical leaf spine topology with all active links and all active switches set up for redundancy. Each server is dual home to a pair of leaves with an LACP of 2 multiple 10G interfaces. There are a pair of leaves that create MC-lag peering through a connection between them, which is called peer link. MC-lag feature provides redundancy and load balancing on hosts. Each leaf is connected to a couple of spines using 40G physical links. The layer 3 termination is on spines with virtual gateway redundancy. For the underlay, we use eBGP unnumbered, which is actually eBGP neighborship between leaves and spines on all physical links, with the difference that the neighborship is done with IPv6 link local addresses. There is no need to set up IPv4 point-to-point addresses. For the overlay control plane, EVPN is used for MAC IP advertisement of hosts across the data center. For the overlay data plane, we use VXLAN. Leaves perform VXLAN tunnel encapsulation and decapsulation. And for the external communication of the data center, we use double physical links, layer 2 VPN, and double eBGP peerings from each spine towards border routers. With regards to the network OS acquisition, we decided to purchase Cumulus Linux version 4.3. Cumulus Linux is widely used in data center solutions. It is a native Linux distribution based on Debian. It is a network OS that runs on switches from multiple vendors and was acquired by NVIDIA on March 2019. Now, with regards to the Cumulus Linux architecture, Cumulus Linux has a process called switchd that peers with a kernel and directly with network ASICs and normalizes the networking model. It also uses FRR routing protocol suite for all routing functions. And also Cumulus authored the NCLU tool, Network Command Line Utility. It is a command line interface that simplifies the networking configuration process for all users. It is similar to the CLI that typically vendors provide on their network OSs. And since Cumulus Linux is a native Linux distribution, almost any Linux tool can be used for configuration and management, and Linux commands and configuration files are always available. For the hardware part, we decided to purchase for the spines the EdgeCore AS7712 series with 32-100G ports and with Broadcom Tomahawk ASICs. And for the leaves, we purchased EdgeCore AS5812 series with 48 10G ports and 6 40G QSFP plus uplink ports. It has a Broadcom Trident 2 Plus ASIC. Now, the solution should not exceed the cost of the budget required for the previous network data center implementations of GRNET using traditional vendors. The cost assessment was made thanks to the TCO calculator previously published by the Whitebox team. So we compared the cost of the spine EdgeCore AS7712 that we acquired with the Juniper QFX 10K36Q that we use as spine to our production data centers. And we found out that Whitebox solution was about 10% cheaper. Now, MCLAG and EVPN multi-homing are two features with the same functionality to provide all active redundancy on servers. MCLAG uses peer link between switches to determine host sharing and primary secondary negotiation, whereas EVPN multi-homing uses the same Ethernet segment identifier value through EVPN to determine dual-homed hosts. EVPN has advantages against MCLAG in that it eliminates the need for peer links or inter-switch links between the top of the racks switches, so we can save some ports to use them for servers and for new hosts. With the MCLAG feature, peer link capacity must increase proportionally to the traffic served to underlying servers. So when traffic and hosts increase, we need to add some more physical links in the peer link lag. And EVPN allows multi-vendor interoperability. For the above reasons, GRNET uses EVPN multi-homing to production disease, but unfortunately, from Cumulus release 4.2, they do not support EVPN multi-homing for Broadcom chipset, so we were forced to use MCLAG to overcome the problem. With regards to the testing part, we focus on 4 main aspects: configuration and management, protocol features and failure scenarios, performance measurements using Hyper-3 tool, and special feature validation. On the configuration and management part, we saw that NCLU commands sometimes give irrelevant and misleading output in comparison with configuration files. So we think that it is more reliable to directly change the configuration files, either manually or through Ansible. The native Linux commands are always available and always display the real configuration status. The documentation for Cumulus NOS has a lot of configuration scenarios and examples that we also used for our environment, but it is not sufficient enough for troubleshoot. On the other hand, there is a very active community via Slack channel that can be of significant help on configuration and troubleshooting. On the protocol features and failure scenarios part, all fundamental protocol features were successfully tested. And despite the disadvantages against EVPN multi-homing, MCLAG feature tests, performance tests, and failure scenarios prove that MCLAG functions properly. And for the performance measurements, we performed many TCP/UDP tests using Hyper-3, producing bidirectional traffic across the servers of the data center. For TCP, we used several concurrent sessions to test load balancing and throughput, and the results were sufficient enough. Something similar goes to UDP, but we use many concurrent streams for testing load balancing and throughput, and the results were also satisfactory. And now, one special feature that we validated is the Mac mobility feature, which is very important on data centers. Quite often in data centers, there is a need to move a host or a VM from one hardware node to another. And EVPN takes care of the movement with the Mac mobility feature, or Mac move, as it is called. During a Mac move, there is an amount of time that the Mac IP pair appears to be advertised by 2 Ethernet segments, the old and the new one. And here comes the mobility extended community attribute. The new segment advertises the Mac IP pair tagged with a sequence number greater than the sequence number of the old Ethernet segment. As a result, the old segment withdraws the advertisement, and all switches in DC forward traffic to the segment that has the biggest sequence number value. In order to test this functionality, we created a VM on server rack 7, as shown in the slide. And we moved the VM through GRNET cluster management tool from rack 7 to rack 5. And from the logs, we saw that the Mac mobility convergence time was 5.8 milliseconds with no service degradation. I think it is also worth to mention the market changes and how they affected the project. Cumulus NOS initially supported several types of Spectrum and Broadcom ASICs. On March 2019, NVIDIA acquired Mellanox. On June 2020, GRNET acquired EdgeCore switches with Broadcom chipset that was supported by Cumulus at that time. And the same month, NVIDIA acquired Cumulus. 1 month later, from Cumulus 4.2 release, EVPN multi-homing was deployed only on Mellanox switches with Spectrum ASICs. So our solution was MCLAG. And on July 2021, from Cumulus release 4.4, it supports only Mellanox switches. So Cumulus 4.3 is the last release that supports Broadcom chipset. And Cumulus release 4.3 becomes end of support on December 2025. This means for us that we have 4 remaining years of support from Cumulus with the hardware equipment that we acquired. This looks like it leads to some kind of vendor lock from NVIDIA, but it is the basic principle of white box concept that gives us the flexibility, since the hardware and software are decoupled, to make a decision in the next few years to either keep Cumulus NOS and try Mellanox switches, or keep the edge core switches and try out another network OS. Thank you.
Thank you very much, Theodore, with this presentation. Is there any question for Theodore?
So I have a question.
Yeah,
what do you think about NVIDIA by now then?
Well, as I said, it looks like it looks like as if NVIDIA, by acquiring Mellanox and their switches and Cumulus NOS to make some kind a vendor lock. And since NVIDIA and Cumulus are competitors, sorry, NVIDIA and Broadcom are competitors in the market, this is not a good case, I think, for us, how things go on.
So you probably, like you said, you need to start looking for another networking operating system, I suppose.
Yes, well, yes, we have 4 more years to, which is a long time to operate the data center, but we need to find a solution about it. Yes, and our first thoughts is to try out another NOS.
But how about the support for the Broadcom chipset then? I can imagine it's not going to be better when they already said they're going to drop it completely, right?
Well, Cumulus says that it drops the support from Broadcom chipset, so I don't know what goes on to other network OSs. We'll have to look to find out what they support.
Okay, thanks. I have a question from Jordi. He sent it to me directly instead of sending to everyone. But no, he sent it now. Did the VM migration have no packet lost? The VM during the migration?
No, it did not have any packet loss. This is what we experienced.
Okay, great. Any other question? No, maybe an answer is to choose an open source network operating system would be maybe safe. I don't know. Okay, thank you very much, Theodore, for your presentation. Now I would like to introduce Dr. Jordi Ortiz from University of Murcia, who have implemented in the context of the RARE project, not really on the context of our white box study, but as in the RARE project, they have developed a rare open system, rare open systems, which is the combination of RARE plus FreeRtrs. They have Jordi has implemented in his own laboratory, which is a network researchers laboratory, a CPE, 2 versions of the CPE with RARE, and he will give us feedback of this. It is in production since several months now. Thank you, Jordi. The floor is yours.
Oh, sorry. So thank you for the introduction, Xavier. Yeah, as Xavier was saying, I have let's say this double role. From one side, I'm working on RER to provide to the community with this open source network operating system. And at the same time, I'm the network administrator of the laboratory in the University of Murcia. I'm working for the Department of Information and Communications Engineering, where I'm also a teaching fellow. So basically, I want to give you a bit of the context of what the lab is and basically how it's. What are we working on? Then I will give some motivations and requirements for this lab and what basically we took into account in order to migrate to RER. Then the initial approach, so how basically we went for it, and then what's the current approach of the laboratory working with RER, with as Xavier was saying, with these 2 CPEs. Already deployed, and finally some conclusions and next steps. So basically, as I was saying, this is the Gaia is the name of the laboratory. You have there an URL if you want to check it. We have been working for long in networking research, and basically the objective of the lab is just to be able to work with the technologies at the moment that we are basically researching through the different projects we are involved in. So for that, we have some, of course, we depend on the university's network. We are connected to Redis and the university's, let's say, the production network for us. But then we have some degree of freedom, so we can we have a couple of IPv4 ranges, 2/24, that we can manage however we want, apart from what the university is doing with the rest of the IP addresses there. And then we have also 5 IPv6 64 ranges. Basically, the lab has been evolving with the technologies that we have been working on. So from that, we had WiMAX research some time ago. Then the SDN was the new HIP, let's say, and we moved to SDN research. Then NFV. So we have a lot of VMs there. We have Proxmox. We have OpenStack systems. We have other kind of virtualization systems. We have IoT was the next wave, let's say. So we started to research with IoT. So therefore we have LP1 connections. We have other works also on security regarding IoT. So we are working on that. And finally, and that's the latest wave of cool words, 5G has come. So we have our own deployment of 5G in the University of Murcia, and we are working basically on right now on making it work, and in the future, of course, in making it worth the promises it's making. So, as you see, we have been evolving, and the question there is, well, we are working in some projects. I just leave them there so that you can check. These are basically the Horizon 2020 and biggest projects we are working on, and basically these projects are relying somehow on the laboratory to make the research they are promising. So basically, we need a stable network, because basically we have sometimes it's the web page for the project. Sometimes we have some components that are accessed by other partners from the project, and basically we need it to work. Okay, we cannot we can do experiments, of course, but we need some part of the network to be stable enough, and at the same time we need part of the network to be unstable enough to do some research. So basically we have these two roles that we have to cover. Okay, so here I'm going to speak mostly on the part that needs to work. Okay, so we had this network working for long, and basically we had some equipment there that was getting quite old, and we needed to upgrade the network. So that was basically the point where we were arriving. So we had 1G network basically on UTP, and we were moving fastly to the requirements of faster network, and therefore we were willing to do these changes. So we had obsoleted routing hardware. In that case, we had Cisco's 7200 working there for a long time, and since most of the network was doing layer 2, and there was not a lot of layer 3 exchange, it was enough, but we reached the point where this was not the case, and we were finding that the hardware was stopping from the evolution. So and we wanted to avoid this vendor lock-in. I mean, because we had in the lab for long we have been doing Cisco for the routing, but then we have Juniper switches, we have HP switches, we have a lot of vendors, and then it's always you need to be upgrading them, of course, and you need to maintain them, and then you depend on the vendor to give continuity to this hardware, right? And for us it's a problem, because sometimes the hardware is not it's not like it's not enough, it's like it's not being upgraded anymore. So basically you are throwing away hardware that for the usage you are doing is good enough, but you cannot upgrade it, and that's a pity. Then about the requirements, so we have these experiments, we have these projects, and some of them, of course, they are using the lab, but we want them to be isolated from one another. So if someone is doing some research on Inspire project, then we don't want them to interfere with what is being done in 5GASP or any other project. So we are using VLANs for that, nothing so fancy, but we have quite a lot of them, and historically we have been doing ACLs in order to avoid routing between them, but at the same time providing access to them to the internet, or just doing some NAT for them, those that they were not using IPv6. Then we use as the services we have in the lab in general for these experiments. We have VPN clients, so sometimes we need to connect to other laboratories, and therefore we connect to other VPN servers in order to extend, let's say, the communication. Other times we are acting as a server, so we have other partners that are connecting to us and accessing our resources. Then we have, of course, the HCP, auto configuration for IPv6, and we were at the point we needed some monitoring, because the network was getting bigger. We don't have an administrator itself. I mean, I'm the administrator, but I do several roles in my daily basis. So it's not like I can be monitoring the network precisely. So having something that helped me and other colleagues on knowing what how the network was performing is something we needed. And we were willing to change, but we were not willing to be, let's say, doing it without thinking a lot on it. So basically, we wanted to have a safe migration mechanism. So basically, that if something happened, we could just roll back to the consistent, let's say, or the old way vendor routing, like the Cisco. So basically maintaining the Cisco as a backup for the process. So as I was saying, so basically the idea was to have this Cisco as the rollback, and we decided to go for the RER. So RER is basically providing based on FreeRtr as the control plane, a data plane to that control plane, and therefore with RER we have two flavors. Let's say we have the DPDK flavor, and we have already heard that with some cards and using the EOMM view, we can reach quite a bit, quite a good bandwidth with standard servers. And then we have the P4 approach, so basically programmable data plane, where you can get a box from EdgeCore or from Stories, APS now, and just put there the software, and you will have routing on line rate with these devices, right? So in this case, we went first for the DPTK, and basically one of the reasons was that we already had some hardware there. It was a Dell R510. It's not really a new one, but it was there. It was from a previous project. So basically the project was ended and we had the hardware there available. So we just put there a card, an Intel XB710. It's a 10G network card with 2 ports. And we put on top of it Debian, where we put RER, FreeRtr, with its DPTK version. So basically, we connected one of the links towards the University NUC, where we have these 2 VLANs that are offering the 2 IPv4 public addressings. And then we have one link connected basically to our internal switching, where we have 19 VLANs, most of them with NAT. So for the layer 2, we have also some white box. In that case, it's a Delta AG7648, which is running TCOS on top of it, so that it allows us to create different virtual switches that, of course, then we provide networking through the RER approach. So basically, just for you to know that we have that possibility there. So the idea was basically to use HSRP v2 with the Cisco 7200. And why v2 and not v3? But basically because the Cisco was old enough not to support version 3, which was needed for IPv6 redundancy. So basically, we said, okay, we will go for it anyway, because we have just one router right now. So we are going to have a redundancy, and that's an increase in our case. But we don't have redundancy for IPv6 for now. And this one is in production since November 2020. So far, the only shortages we had in networking were because or either power shortages in the laboratory, either I did something wrong in the configuration. Apart from that, the router based on the server is working perfectly, and so far we don't have any kind of problems with it. So this is what basically we wanted to do. So we have this VLANs here on the bottom, and we had the RER FreeRtr with DPTK, which is doing these 3 BRFs at that moment. One was for basically for the work we were already doing with the Cisco, which is the iNet BRF, let's say. And then we had another 2 for NMAS, one for related to the RER project, and the other one related to QEMU access to NMAS, so for extended monitoring of our lab. So this one, let's say that was the first approach. But then we knew, I mean, as part of the RER work, we put a wedge, an EdgeCore wedge 32 there. It's 32 ports 100G. And we put it to connect it to the GÉANT P4 lab, which is another work we are doing within RER. And that one, we decided to put it also as part of our network. So basically, since we had already some experience with the DPTK version, and we were quite comfortable with how FreeRtr and RER were working there, we decided we could go also for redundancy using the wedge, which was connected through Redis also to the P4 lab. And this is something quite interesting, because for this connection we had 100G ports, but actually Redis still was 10G in Murcia. So basically we had to downgrade our connection to the Redis in that case. And now they are moving to the 100G, and hopefully we will be doing directly 100G to the laboratory, to the GÉANT production, let's say, laboratory. So this box, we had some P4 devices. We acquired actually 3 of them because of different funding, and that's quite a point. So basically, we get funding from the projects to purchase hardware for research. So we don't get really budget in order to get production, let's say, hardware. So anything we have to buy, it's intended for doing research and producing some knowledge. If it's not for that, then we don't buy it, basically. So basically, we bought these P4 devices. These are based on Tofino, Barefoot by those days, now Intel. And basically, what we did there is to use to put this box apart from the work that was already doing for testing within RER, to put it also as production for the laboratory. So basically, we put there a VRF that would do the same iNet, let's say, as in the DPDK version. Only thing we cannot do with this box is basically provide with the NAT access to the 19 VLANs, basically because of a limitation in the number of translations we can maintain in time for it. So, but for IPv6 and for public IPv4 addressing, there is no such limitation. So basically, we are using, in this case, HSRPv3 with the DPDK router. So now, at this point, we just put it there, and basically we had them working all together. And at some point, so basically in September 2021, we put the wedge as the biggest priority, and from that point, the wedge is basically managing the public addressing and the IPv6 addressing for the laboratory. It has too many ports for us, so basically it's 32 ports with 100G. It's more than we really need. So basically, we have another test which was already going on, and we decided to maintain it because we really needed 2 ports for this work, which is the 100G test. So basically, what we did is we put some DAC cables doing loops in our wedge, and with that we did some configuration, putting several VRFs, and we inserted traffic at 100G with a server which we had connected to it, and we had several terabit, something like 1.8 terabits per second going on that switch, while it was also doing the production routing of our lab. So basically, even if our lab is not doing a lot of effort for the device, we have this test running at the same time, so we know that it's able to cope with it. So this would be, let's say, the double role, right? We have the testing of the RER at full speed, and then we have also the production of the lab working at the same time. So right now we have the Cisco just as a fail-safe for the NAT, and it's something mostly until I convince my my colleagues just to remove it, because really it's not coming in at any moment. So even right now the Dell is in one building and the wedge is in another building. So basically, it's not a problem of power shortage right now. It's really difficult that both buildings come down, and basically the Cisco is not being used a lot. We have adopted also VRRP. So because right now we have the wedge and the DPDK version, and basically we thought that going for a more open solution than HSRP, which is Cisco proprietary, would be better. Then we are using OpenVPN and WireGuard client server from the DPDK, and that's really a very good capability that it provides, the DPDK version, because basically it's a server itself, so you can run tunnels on top of it, and since it has 16 cores right now, and I mean we could get a bigger server at any time if needed for that. It can maintain the tunnels directly from the router instead of having VMs that then you have to connect to the different laboratories abroad. So basically, we can centralize the way the VPN connections are working for the laboratory, and that's really something interesting. We were thinking in maintaining the DHCP server on the Cisco or migrating it to a Linux box, but finally we are using it on FreeRtr. That's that came as a surprise, let's say. So basically, we decided to go for FreeRtr for the routing just, and then we found a lot of capabilities inside of it. DHCP would be one of them. And yeah, we are using it every day. We have the metrics exposed with Prometheus, and we have Grafana panels to check exactly what is the status of the traffic for both the DPDK and the P4. So it's a common interface just to monitor easily and at one shot what is going on the network. So basically, we have the wedge running Debian and rare FreeRtr. Yeah, okay, 5 minutes. And rare FreeRtr directly, and that's an option for rare in particular. And with that option, you basically just need to reboot the machine when you switch the kernel. So when you want to get the latest kernel on top of it, and let's say, and I have to say, we are getting new kernels not so often, and it's your call basically to do it whenever it fits you well. And then we have another P4 box, which is the APS 2556, which is also running rare, but in this case it's a NIX version. So that means that we can roll back different versions of the software basically live. So we can just put a new version. If it doesn't work well, we just roll back and we have it working. So it's not and it's not dependent on the environment, let's say. So it doesn't depend on Debian doing putting new version of OpenSSL, because basically everything inside that version of FreeRtr is completely independent from what is surrounding it, and it's I think it's a good option for the future. We are moving from ACL isolation to VRFs, so basically now we are doing VRFs, and that's basically a bit what we have now. So we have the tunnels on OpenVPN and WireGuard. We have the wedge doing with the P4. We have the Dell with the DPDK. We have the experiments going on, and then we have the several slides, let's say, slices for each of the experiments. And we have HSRP between them. And as I was saying, the Cisco is going to be thrown hopefully soon. So what are my conclusions and next steps? I'll try to go fast for this one. So basically, as I was saying, we are willing to remove completely the old Cisco. FreeRtr has fulfilled completely the laboratory requirements, and we are really happy with it. More than, I mean, it has overworked what we were expecting from it. The reliability is comparable to traditional solutions. So basically, we didn't have any kind of drawback in these months working with the rare option. We are willing to do virtual instances of DPDK rare FreeRtr. So we have already tried to do it once, and basically it was working, but we had some performance issues. And as I said, since we have multiple roles, and in particular me, I just put the time when I have it. So the playing time, it's not so big, but I will for sure have this virtualized version. And that's why the Mac migration was really interesting for me, because I think it's something really interesting for this kind of approach. We have this APS box, which is more versatile in terms of speeds. And this is something that we will probably put instead of the wedge, because the wedge is really big for the task we are putting on top of it. And basically, if you are running IPv4 without NAT or IPv6 only, P4 can be completely your choice. If you put FreeRtr on top of it with RER, it will work perfectly. And then if you still need the NAT or heavily NAT, let's say, because you can do NAT with the P4, but you will be quite limited in terms of size. But if you need big NAT, then you have the DPDK as a good option, as I was saying. And that's all. I think I really ran out of time.
No problem. Jordi, thank you very much for your presentation. You are in vacation, but as you are passionate by your work, you kindly, because in Spain it's a bank holiday today, so thank you very much for your availability.
No problem.
Is there any question for Jordi from the audience? For me, I have one question to start with RER. RER started, of course, on the P4 chipset, so after that there is a DPDK version. So now I think that you would develop new use cases, I would say. So for now you have the CPE, but maybe we could implement with DPDK, I don't know, a router for university, a router for campus, or for regional network, I don't know. Is it something that you are working on?
Well, within RER, we are working on different use cases, as you were saying. In our case, in the university, we are limited to our scope, but as part of the GÉANT project, we will for sure focus on bigger, broader scenarios. And actually, I think the case for the regional network in France, for instance, is a really good example for it, or the one for the limitations of Cumulus is also a good example for why RER could be an option. So yeah, I think we can go for it.
We have a question for Dennis. Dennis, would you like to ask it to tell it, or?
Yeah, sure. I was asked if this is a streamed telemetry or some other metrics you're getting from this P4 stuff.
Yeah, basically the way this is working, we have the sensors concept inside FreeRtr. So basically, you can put as a sensor almost anything that you have in hand. So you can, let's say, expose part of the control plane or part of the data plane values. And once that is done, you can export them through several ways. So you can, let's say, copy them via HTTP. You can use Prometheus. Now we are moving to Victoria metrics because we found a limitation in Prometheus. So basically, once you have exposed the data, let's say, you can copy it or retrieve it in several ways. In this case, from Prometheus, if I'm not wrong, is just getting, I mean, the Prometheus server is connecting to the box to get them. It's not like you are sending them, pushing them. But there is the possibility. And actually, one of the ways of doing it is via HTTP. You can just, there will be a push via HTTP to it.
And I can add that is really not pushing too much traffic. It's really, really thin traffic. And you can have, on Prometheus, you can have your value each 15 seconds. So it's very, it's quite interesting. Please go on, Dennis, if you have.
Oh, that's good. Thank you.
You're welcome.
Is there any other question for Jordi? Tim?
Yeah, I was just going to ask whether you managed to test RER up to 100 gig. I missed if you mentioned that in terms of performance.
You mean the 100G test?
Yeah.
No,
it was mentioned during the
yeah.
Okay, sorry.
Yeah. Basically, I mean,
I'll look at the slides.
Yeah, that was actually something we did kind of ad hoc. Basically, it was a conversation with Sava. He said, "Hey, why don't we try to test the 100G?" And then I said, "I have some spare DAC cables," so we put them there, and Sava did the coding for the several VRFs, and then we started to put the traffic, and and it's running there since we put it. So basically, I didn't stop the machine from sending traffic, and at the same time we have the production traffic on that same box, so it's working perfectly.
Okay, great. Yeah, that's something we hope to report on early next year. There are other rare performance tests happening in a lab at PSNC, I think. Also, the Data Mover Challenge used it at the University of Amsterdam, and the worldwide data transfer challenges that are happening there, we're getting 85 plus gigabits a second. So it seems to be performing very well. So thank you.
Thank you. With this, I think we will, it's a perfect introduction for the next talk. Thank you very much, encore Jordi, for your availability. Tomasz Szewczyk is from PSNC work on white box, also on rare team. He's targeting performance because it is an obvious subject to qualify or to validate a device when we want to install in our backbone. So, Tomasz, please, the floor is yours.
Thank you, Xavier. Hello, everyone. I'm Tomasz Szewczyk, network engineer in PSNC, responsible for CRIANN network. Today, I'd like to give you right now a very brief overview of network device validation, network platform validation. The topic is pretty wide, so I will just focus on the context of white boxing. So first of all, as you heard during previous presentation, there is still a lot of research based on the white box platform. So I'm trying to ask a question. Can we consider white box as a well-known platform, or still there is something to look inside? So can we treat this as a black box? So this is why we tried to propose few topics to cover in order to prepare device validation procedures. And at the end, I will present you some tools we used in our experiments and provide you some example results. So first of all, you know that the white box already consists from hardware and software, which in case of device under test have differentiated properties. In case of hardware, you can look at network processors or chipsets, size of TCAM or FIB. You can also verify the number of matching conditions in the routing table, or how the packet processing pipeline is constructed. So next important property is the buffer size, which may influence your traffic depending on your use case. And of course, if you think about modular devices, they can have very complex switching matrices. So in case of software, on the other hand, we implementing a pretty large number of signaling protocols. We deploy a number of differentiated services. And as well, we have to provide a driver between the software functionalities and the hardware device. So in case of device under test, as I said, we have hardware and software coming from different vendors. This is, I would say, great opportunity to choose the proper devices and proper software for our needs. However, we have to be sure that those two are interoperating properly. Because if you compare it to legacy vendor, then you're just getting hardware and software out of the box, and you, in fact, don't have to worry about anything. However, if you go in the white box direction, then with the new opportunities, you have to consider a little bit more technical parameters. So how to look inside our black box? First of all, we need to check or verify how the control plane works, how our device will be managed, and how the signaling protocols will operate on this. And the very important aspect of white box is also how the NOS network operating system is able to set up various hardware parameters on the underlying device. So in other hand, the data plane test, so the hardware, has, as I said, given properties which results in switching performance, FIB size, and congestion management. Because if we consider a network with multi-path topology, then we should expect congestion in our network, and we have to decide how to manage this. Additionally, we choosing a white box in order to meet a given to meet our needs. So basically, we looking for the device which will be good for our use case. So the use case testing is very, very important. So we have to define a test which will confirm that the device is meeting our expectations, and if it performs at a certain level, we require. And of course, we have to be sure that this device is also future-proof. So we need to check if it has sufficient capacity. Okay. So first of all, let's have a quick look at the control plane tests. Thanks to virtualization, a lot of this test can be conducted in a virtual environment. You probably know that even legacy vendors are offering virtualized versions of their boxes. So you can play with Juniper, Cisco, and Arista in virtual environment. And you can do so in most cases as well with white boxes. And thanks to that, you can check the interoperability of your solution. You can verify basic scalability parameters, and you can also in the virtual environment deploy management and configuration maintenance procedures. So you can also at some point measure the network convergence time from the perspective of routing protocols behavior. It's quite important to note here that one of the key parameter influencing the network convergence time is not just the machine of state of given signaling protocol, but the detection of events appearing in the network. So some of those related to protocol operation you can verify in virtual environment, some you need to check in the real deployment. So the next topic, very important in case of white boxing, is how the software interoperates with the hardware. In our case, we have to look that our chosen software NOS has fine support for given a hardware box. And this is something we have to verify if this what was planned or deployed on the control plane was properly transferred to hardware. And first, very important, of course, question here is if the header operations are performed properly. So I mean the different push or swap operations, and if the next hop was selected and programmed according to current state of our routing table. In other hand, the data plane tests should allow us to verify if the device itself is able to switch the traffic at certain level. And you need to look at this from the perspective of frame sizes, because the construction of switching matrix depends, the switching performance depends on switching matrix properties. We are trying to during our test, usually I'm testing the device with minimum frame size, maximum, and then with mixed size packets called iMix, which represents the internet mix, which is in fact the reflection of sizes of packets you can see in the internet. And you have also predefined benchmarks test. There are a couple of RFCs defined, which defines certain testing procedures, and this allows you to build your test according to the similar algorithms. And thanks to that, you can be sure that even if the RFC-based test was performed on a different testing platform, your results will be similar, or you can compare those results. And there's a list of parameters you can measure: this throughput, forwarding rate, caching capacity, and so on and so on. This also depends on the type of transmission you use. You can use for unicast, multicast, and broadcast if you need it. And another important topic in case of data plane test is congestion management, which is the capability of the device to handle congestion on egress interface. Of course, if you have the device with a number of interfaces working with the same speed, it might happen that two interfaces will try to send traffic to a single interface, and you have to manage that congestion. And this is dependent on size of buffers. And the final step in testing is use case testing. Once you are sure that your device is operating meets the scalability parameters and functionality parameters from software point of view, and switch the traffic very efficiently, then you can implement your use case. So you can verify how the device under test operates in configuration you're expecting to have in your real network. In order to do so, you should be able to emulate or provide elements of your future infrastructure. So basically, if you would like to test how your device will operate in a network consisting on 100 routers, then you have to emulate somehow this environment. Next, once you have your network topology established, then you need to generate the traffic which will pass through that infrastructure, which should be also a reflection of services deployed in that use case test. So basically, you can verify operation with multiple predefined parameters which are important to you. And our experience in PSNC is that it allows you to verify in detail the datasheet parameters, because in most cases, if you see the datasheet, the vendor gives you the maximum numbers of given parameter. However, very often the parameter is measured as a single test. So you can say, for instance, that you have 1 million prefixes for IPv4, and I would say 600,000 prefixes for IPv6. However, you should ask the question, how many prefixes I can have for both IPv4 and IPv6? And this is what you should verify during use case testing. Okay. So in order to do that, you need to use a number of tools. You saw during the previous presentation that our researchers were using device tools which are available for them. However, in order to make this on a very, very high level, you need to consider using hardware traffic generators or advanced software like iPerf, Scapy, or T-Rex. In case of traffic generators, you have a variety of devices available. The most basic one are handheld devices, which are small, usually devices built in order to test, for instance, Metro Internet Forum specifications or so on. However, what is important in terms of hardware devices, they are able to insert hardware timestamp in the packet you send to the network. So basically you are able to verify the time-related parameters like jitter or latency. And additionally, as I said before, you should be able to emulate the network topology, which allows you to validate if the traffic is passing through your infrastructure correctly. Additional topic, which is maybe not so important in terms of devices we are talking about here, is the stateful or stateless stream generation. Mostly from the IP perspective, we are talking about stateless streams because we don't care about establishing TCP sessions and so on. However, Jordi mentioned that some software offers ability to perform a NAT, which is a stateful mechanism. So basically, in that case, you need to generate a stateful stream as well in order to verify how the device operates. And in terms of systems built with hardware devices, there's also nice feature introduced by vendors, which allows you to build virtual ports. So you can deploy a testing port on some virtualized infrastructure. So in case, by the way, the example, you can deploy your virtual router on server and connect the traffic generator also as a virtual machine to it, and you can start your testing. Okay. What is also important topic in terms of using or making the test with emulated topology is ability to bind a traffic streams to emulated topology. It's not just the case when you like to emulate a number of BGP peers advertising a number of prefixes, but you will also like to verify if the traffic is switched according to that emulated topology. So as you see here on the slide, you're emulating some virtual infrastructure on the left side and on the right side of the DUT, and you are not interested only in case that the DUT will switch traffic from one interface to another, but you will also would like to verify if the traffic generated from VPN side on the left side will be delivered to proper VPN side on the right side. So this is very, very important topic in case of validating network devices. So the testing equipment provides you ability to insert stream ID and introduce a sequence number. So basically, you are able to verify if the traffic stream you received on the receiving side has correct ID, so it was delivered properly, or it was delivered according to the given sequence of packets. So there was no roundering. Yet another topic in case of testing is also automation. The RENATER team, there are guys deploying new features very fast. There are new releases of software almost every week. So basically, they need a tool which allows them to validate the status of the implemented software in the automated way. You can also apply this approach to any other tests in your infrastructure. So basically, you can prepare of measurement steps and procedures to repeat those steps during each test. So you can then easily compare results between the different tested devices. And as well, you can easily define a pass or fail criteria. So it allows you to verify quickly the results. Okay. So now I would like to give you a brief, few brief examples of tests we performed with white boxes, and what is important. There was iterative process of testing. We we were what we are looking for, because we defined few use cases and we tried to verify device operation for that. And strength of our team was also that we knew how to find it. So in next slides, I show you how we tested the MPLS core devices. So use case for building LSR based on white boxes. And then I'll just give you brief information about buffer size testing. So my first contact with white boxes was when Xavier asked me to propose a real use case for white boxes in our network. I thought that we can start to build MPLS LSR, because that would probably be a very cost-efficient solution. We'll get a number of high-speed ports with reasonable price level. So first of all, we have to find a network operating system with MPLS support. In that case was IP Infusion, OCNOS. And we had a few platforms, hardware platforms supported by those NOS. It was EdgeCore and Dell devices. So we started to build our test. And as you can see here, we generated the device under test in the middle of our testing environment. On the left side and on the right side, we emulated a number of intermediate label switch routers with ISIS protocol established. Then we established transit LSPs passing through the device. And what we verified was if the LSPs was established properly between predefined endpoints, and if the traffic was transferred properly. So this is a brief example of what you can see on Spirent Test Center platform we used in our testing. So you see we emulated here ISIS topology, which consisted of 4 routers. We also directly connected routers. We also generated RSVP neighborship. And after that, we defined LSPs, which were passing through the tested device transparently. And what is important topic is that after that, we built that topology. We started to generate a traffic basing on that emulated control plane and connected to the device under test. So as you can see here, on the left side, on the right side, you have ability to choose the endpoints on emulated infrastructure, and then once you select a pair of that endpoints, you can define traffic which will be generated for that endpoints. And during our tests, we received some questions from REN about buffering capabilities of white boxes. So using that topology from previous use case, so MPLS LSR, we built up the test which allows us to verify how the device under test will handle overloading of the egress interface. So we generated 2 streams of packets on egress interface, which was adjusted to overload the egress interface. So what we've done, we created a test procedure which we changed the number of packets sent with maximum speed. So basically, if you have 2 interfaces and you start to send packets with maximum speed, then the egress interface, of course, will be overloaded. And using that procedure, we was able to identify the size of buffer of tested platform. In that case, you can see that this is about 72,000 IMX packets. Okay. So as a summary, I just want to underline that network operating system should be evaluated by network providers or brands from the functionality perspective. So you are interested in getting a set of features which are important to your particular use case. And in case of white boxing, the overall solution performance depends on hardware platform and the NOS used. Because you can, of course, get a brilliant network operating system, but when the hardware is not designed properly, then your performance will not be good, and vice versa. And so during this validation procedure, you also should be able to define the maximum performance values, because it can happen that it will differ a little bit from the values you get in data sheets, because as I said, in data sheets, the values are tested in individual tests, but we are interested in maximum values in our environment, in real network condition. So what is also important from our experience is that we need probably a test platform combining hardware and software resources for brands, because during the previous presentation, you saw that people are trying to make a test in distributed labs, and probably it will be good to, first of all, provide some resources for testing of that equipment, but additionally, you can probably define a way how to share information coming from that test. And as a reference, you may see a document we produced, which discussed this topic a little bit in more detail. You have appendixes with live results, and you can see what was details of our test. Okay, thank you very much.
Thank you, Tomasz. Is there any question for Tomasz? Do you have make also some tests on your side on your hardware? Are you really interested to test some hardware before making some performance tests before put this in production? No? No, okay. So if there is no question, we will stop this here. Thank you very much, Tomasz, for your presentation. What we would like to now, it's the time for a short discussion about this. We would like to ask you if you have your feedback on this topics. So we have organized a very quick Mentimeters where you could put your feedback on it. Let me share my screen. Here it is. You can connect on this mentimeter.com with this use code, and so far you will be able to join. What also the first questions I would like to share with you is I don't see if you see my screen for now. Do you see my screen? And you see the result of the vote or not?
Yes, we can see it.
Ah, okay, perfect, wonderful. Okay. So for now, there is no white box in production from the audience. And, well, the questions that we would like to ask to you is whether you would be interested, and do you think that there is potential use cases? It's very brief, discussion on. Do you have any also? It's an open question. If anyone wants to answer directly, do you have any project related to this, just to test it, or no? Okay, so there is for now. There is 10 answer. I think we have almost reached the. I will answer yes because me I have one, and so we can.
We know at least two.
Yeah, at least two. Yes, exactly. So let's go to the next question. Do you plan to implement the white box in your network? Do you have any things that you have already no plan at all? So me, I can answer already that I have. Okay, this is interesting because it seems that it's not a really people are still are not really enthusiastic to investigate this for now.
Well, Xavier, I think we are in small group. In fact, because today I just got information from our HPC administrators, so they are interested in deploying some Cumulus-based scenario in the future. So it also depends the audience you're asking the question.
Yeah, no problem. Thank you. No, but there is already, for instance, Switch, the Swiss NREN, has already implemented some also some data center based on the white box. So it's already something that is, the point is to change a little bit the use cases, which is more focusing on at the edge or in the data center, on started to have some use cases that is more related to the backbone or to different application of the network of the research and education network. So if you have no white box in production and no plan to test it, and or we don't plan also to implement it, what is your concern or obstacle? Having support, yeah. This is something that reliability, stability, platform knowledge. So for the platform knowledge, to be honest, one of the conclusions of this work is finally there is, I would say, not a long time to understand how white box work, how ONI works, and so on. And after that, for the network operating system by itself, it's not so complicated. I think that that it was not so different from what we used to do. So, NOSes, hardware support, stability, yeah. So when I see stability and reliability, for me, it means that the platform that Tomasz proposed, presented, is certainly something that could reassure you. So thank you for this. Which use case are of interest to you for regarding using a white box? In RENATER, we plan to. It's still a project, but it's typical. We plan to use Whitebox for managing our private billing routers, for managing our private billing, because we have some private billing with Google and Apple and so on, and it's quite expensive to connect it to our Juniper. So having a white box between the private the operators on our ISBR or Juniper would certainly save a lot of money for us. Great, thank you. Yeah, so limit the set of protocols is yes, it's something that we don't speak a little bit, but when you have a white box, there is sometimes, at least for the ones that we test in RENATER, you have to choose a kind of profile. So if for instance with Ocnos, you say, okay, you would like to have more layer 2 address and less no IPv6, just part of IPv4 address and so on. So you choose more if you would like to be to use your switch for layer 2 or for layer 3 or something else. And this is because the resources of the white box is limited in general. Okay. Thank you for this. And how can we help you if you have any test? I would say the GÉANT project, not me. It could be also something that could be handled during the next project. I don't know something if there was some concern about reliability. Maybe you may would like to have a kind of platform where you test a machine. You can also would like to have some experience in to have some feedback of deployment or of tuning machine or something like this. I don't know. Okay. I don't see any new input for this. Okay. Oh, sharing experience, validate use case, description, deployment guide. Yes, that's a good idea. Performance test result. Yes. There is also the possibility to share some deployment platforms. So, for instance, if we have, if we could set up, I don't know, platform traffic generator, if we can share between the NREN, it could be useful for validate. Something like this. Rare with Broadcom, it would be really nice, but we have to have access to the SDK. This is something that is okay. Thank you very much for answering to this poll. I think that we have already behind schedule. Performance test on valid scenario. Yeah. Okay. Great. Thank you for this. Do you have any comments that you would like to tell or something, suggestion? If not, we can maybe stop here. I would like to thank you very much, you to attend to this InfoShare. Thank you to our speakers, and hope that you can benefit from all the documentations that we provide to us. Thank you very much.